Hi guys, today we are going to see about matrix operation. So first matrix operation is equality of matrix. When we can say two matrices are equal, if the corresponding elements of a matrix are equal, then only we can say that matrix are equal. Consider this matrix A. A is an element matrix with dimension 3 by 3 and A is also 3 by 2 and their corresponding elements is also equal. Corresponding elements is also equal, right? So is all the corresponding, that is A11 and B11 is equal. Similarly, A23, A33 and A33 is also equal. Then we can say A is equal to B. So if two matrices are equal, then the order or dimension will also be equal. So the properties of equality. If A is equal to B, then B is also will be equal to A, right? Can you able to see the last slide? That is A is equal to B, then B is also will be equal to A. And similarly, if A is equal to B and B is equal to C, then obviously A and C will be equal. Okay? Okay. Using the equality matrix, find the value of x, y and z. That is, these two matrices are equal. Yes. Then what is the value of y here? That is corresponding element here. That is here it is B11. A11 value is 4. So what is the value of y? 4. Similarly, what is the value of z? It will be 3. The value of z will be 3. The value of x will be 1. So value of x will be 1. Okay. So I will frame a sum like this. X plus y 3, 4, x minus y is equal to 6, 3, 4, 0. What is the value of x and y? If they ask like that, what we can do? So corresponding element of x plus y, what we have here? 6. So x plus y will be equal to 6. Similarly, x minus y will be here 0. Now we formed a pair of linear equation. So whatever method you know, you can able to strike it out. You can get 2x is equal to 6. So x will be equal to 3. If x is equal to 3, and what is the value of y? Y will be also equal to 3. So this is how the equality of matrix works. Okay. Next operation is addition of a matrix. Now we can add or subtract a matrix only when they are in the equal dimensions. If I am taking a matrix of 3 by 3 and B matrix 3 by 3, then only I can add or subtract. Okay, so order or dimension of a two matrix should be equal to perform the operation like addition or subtraction. And after that, what I will do for addition, I will add the corresponding elements of the matrix to form a C matrix. That is, if I want to, what I will do in the resultant matrix, that is C matrix, which is equal to A plus B. So A11 plus B11, that will form my C11. C11 will be equal to A11 plus B11. So I will show in the example. See here, if I am having a two matrix of dimension, this what you know the dimension of this matrix, right? What is the dimension of this matrix? 3 by 2. And this matrix is also 3 by 2. So now I am going to add this. So what will be the addition of 5 plus minus 2? That is forming the resultant matrix, which is going to be equal to, what will be the resultant matrix here? 3 minus 2, 0, 4, 4 and 4. Okay. So how I form this? By adding the corresponding elements, that is 5 minus 2, here this symbol is plus. So 5 plus minus 2 will be my 3. So this is the C matrix and this is the A matrix and this is the B matrix. To form the C matrix, what I did? A11 plus B11 to form C11, right? Okay. And you want to note that the resultant matrix, what I got also will be in the same order what my input matrix are, that is A matrix and B matrix are. Not possible because order of this matrix is not same. That is, this is 3 by 2 and this is 3 by 3. So we are going to see some important properties of here addition. Addition or subtraction, both will follow the same thing. If I am having a subtraction, then what I will do is I will subtract instead of addition. Since operation alone will change. So what I will do, if I want to subtract 5 minus of minus 2 and 3 minus 1 and minus 3 and 4 minus 0 and 0 minus 4 and 7 minus of minus 3. This is going to form, what is going to form is, that is 7 minus 4, 4, 10, minus 6, minus 4. So this is the resultant matrix of, this is A minus B. Okay, this is A minus B. And this is A plus B. What we got already is A plus B. Okay. So some important properties of addition and subtraction. Yeah, commutative law. Addition is a commutative, right? So similarly, but subtraction will be not be commutative. That is, A plus B will be equal to B plus A, but A minus B will be not equal to, A minus B is not equal to B minus A. So subtraction is not a commutative. So whatever capital letters I used here is a matrix. You want to consider this as a matrix. So capital A means you want to consider any order matrix, but A and B matrix should be a equal matrix since we are going to add it. And it is going to follow the associative law. So associative law, you know, right, what it's going to be. So A plus in bracket of B plus C will be equal to in bracket of A plus B plus C, and which is also going to be equal to A plus B plus C. So this matrix addition is going to follow the associative law. Then we have a identity element. Identity element. So you remember this, it is not 0, it is a 0 matrix. If I remember the types of matrix, I said about 0 matrix or null matrix. What 0 matrix is? 0, 0, 0, 0. So whatever order let it be, but all the elements of the matrix should be a 0. Okay. And what is this? This is inverse elements. So I can able to form the inverse by, that is negation of A. If I going to get my identity element, what is going to add? This is known as inverse element. Here minus of A, negation of A. What is the meaning of minus A? If I am having a matrix A called 1, 3, 4, 5 and I am going to form minus A matrix, that is minus 1 will be multiplied through each element, that is minus 1, minus 3, minus 4, minus 5. So this is known as negation of matrix. If I add these two matrices, that is A plus minus A, I will get matrix of null. So this is what this property says. Okay, next we are going to see about the scalar multiplication. Guys, don't confuse it, there are two multiplication. Here we are going to consider about scalar multiplication. So what is scalar? It's a single constant element, that is here it is K. But A is matrix and K is element, that is scalar value. So this scalar value will be multiplied with a matrix which will be equal to matrix into that multiplication of scalar matrix. And once again it is a commutative law, right? So that is 4 into A matrix will give the answer of matrix into 4, which is both going to be common, that is 4 3s are 12 and 3 4s are is also 12. 4 into minus 1 is minus 4, minus 1 into 4 is also minus 4. Okay. So these are the some important properties of scalar multiplication. Here capital A and capital B denotes matrix, whatever order, but both A and B should be have same order, and K value is some constant value, some scalar value. And I am giving you assignment as, guys, please do this assignment, that is properties of this. You want to take any two matrix, that is A and B of same order, because we are going to add it, and take any singular value A and any singular value G and prove this 4 properties. So for you, I will do first proving and you want to do next 3. What first property says? So guys, what is the first property says? K into A plus B is going to be equal to Ka plus Kb, right? Okay. I am going to take two matrix, which is A is equal to 1, 2, 3, 4 and B matrix as it should be of same dimension of A. You can take whatever dimension, but A and B matrix should be equal because we are going to add it. So 3, 1, 2, 4. I am going to take like this. So first I am going to take this side, that is A plus B is going to be equal to, what is my A plus B? That is corresponding elements I have to add. So 4, 3, 5, 8. Right? Okay. Then what is going to be a K value here? I am going to take K value as 5. So what I am going to do? 5 into A plus B, which is going to be equal to 20, 15, 25, 40. Then what is going to be Ka value? So what is going to be Ka value is Ka, which is going to be equal to 5A, which is going to be equal to 5 into what is A matrix? 1, 2, 3, 4. Right? Which is going to be equal to 5, 10, 15, 20. Similarly, what is going to be my 5B, which is equal to 5B is 5 into B. What is the B value? 1, 3, 3, 1, 2, 4. It is going to be resulted in 15, 5, 10, 20. So 5A plus 5B will be equal to, what will be my resultant matrix? 5 plus 15 is 20. And 10 plus 5 is 15. And here 25 and it is 40. So this is my 1, this is my 2. From 1 and 2, what we are concluding? The property of Ka plus B is equal to Ka plus Kb. Hence, true. Right? Okay. So like this, you also do all the properties. Take any two matrix, whatever it is assigned in the capital letter, this matrix, take it equal dimension since we are going to add it. K and G is going to be any two integers. K and G is going to be any two scalar value.